Wonderful. God is good. You're all welcome to my channel, Make Boss channel. We are continuing with the part 2 of Binomial Theorem. And remember our hashtag, you don't need to be a scholar to get an A. Yes. And this is my YouTube handle, Make Boss Tutorial. You're all welcome. Now, we've talked about the part 1 under Binomial Theorem, where we talked about the meaning of Binomial Theorem. We also talked about the methods of solving an expansion, and I introduced to you 2 methods. The first method is using the Pascal triangle, and I also introduced to you the idea of combination. So today we are going to be solving more examples. Remember I said we are going to be focusing more on the idea of combination. So we are going to be looking at more examples under combinations. So welcome to Binomial Theorem part 2. Let's dive right in. Okay, just a quick reminder. This is the formula for the binomial theorem. The binomial theorem for all values of a and b, provided n is a positive integer, is given by, and this is the formula. I explained this formula in the last class. I explained what combination is in the last class. So let's continue with our examples. Now look at this first beautiful example. It says, find the first 5 terms of the expansion 1 minus 2x raised to the power of 10 in the ascending powers of 10. What does that mean? The ascending powers of, when we say 1 minus 2x raised to the power of 10, x can have a value from 0 to 9. Is that okay? X can have a value from 0 to 9. So in the ascending powers of 10, of x rather, we have x raised to the power of 0, x raised to the power of 1. So looking for 5 terms, we're actually going to stop at x raised to the power of 4. So 0, 1, 0, 1, 2, 3, 4, and that will give us 5 terms. Is that okay? Okay. Now, let's interpret this question. This question says 1 minus 2x raised to the power of 10 equals, okay, whatever. Now, we have our formula, main formula to be a plus b raised to the power of n. So we want to make this question to look like these are general formula. Now, looking at this question, we can see that, of course, a will be equals to 1 and b will be equals to 2x, right? But this plus is our problem now. How can we do it? We can just separate it and introduce plus sign here. We know that plus minus will give us what? Will give us minus. So we have not actually changed anything here. Is that okay? Okay. So in this case now we know our a is equals to what? Is 1, and our b is equals to what? Minus 2x. Please, if you have a question of this form, make sure you always represent it like this first before you start solving. If not, you will get a wrong answer. Okay. Now, hope you remember this formula that we introduced in the last class. We said n combination 0, a raised to the power of n, b raised to the power of 0, plus n combination 1, a raised to the power of n minus 1, b raised to the power of 1, and so on and so forth. Let's use it in our formula. Now, in this first question, if you notice, there is no combination here, unlike this 10 combination 2, and so on and so forth. There is not here because it has been simplified. Now, this what actually is supposed to be here is okay, I'm writing it at this side, is actually supposed to be 10 combination 0. Then our a here is equals to what? Is equals to 1 raised to the power of 10, right? And our b is what? Minus 2x, right? That's minus 2x raised to the power of 0. That's following this. This is what I'm following. Is that okay? This is similar to this. Now 10 combination 0, using the idea of combination, we can say 10 combination 0 will give us 10 factorial over 10 minus 0 factorial. Are we following? 0 factorial. Now, something you should know is that 0 factorial is equals to 1. Is that okay? So 10 minus 0 factorial will give us 10 factorial over 10 factorial times 1, right? Now, this 10 factorial cancels 10 factorial. Everything gives us what? Gives us 1. So 1, and minus 2x raised to n raised to the power of 0 is equals to what? Is equals to 1. 1 raised to the power of 10 is also equals to, so 1, we get 1 here, we get 1 here. 1 times everything gives us what? 1 raised to the power of 10. Do you see how we got 1 raised to the power of 10 here? So you do not need to write this long stuff. You can just bring your first term and you impute your first value. Impute your raised to the power, which is 10. Is that okay? Okay, I'm sure we got that. Let's continue. Now our second term, which is n combination 1. Our n here is what? Is 10, right? That's 10 combination 1. Now our a is equals to 1, right? That's why we have 1 here. And we are having n minus 1. That's 10 minus 1. 10 minus 1 is equals to what? Equals to 9. And our b is equals to what? Minus 2x. Is that okay? And minus 2x raised to the power of 1. So these are second term. Our third term says n combination 2. That's 10 combination 2. Then a is equals to what? Is equals to 1. Our n is equals to 10. 10 minus 2 is equals to what? 8, right? That's how we got 8 here. Our b is equals to what? Minus 2x. And what do we have here? 2, right? So minus 2x raised to the power of 2. Okay, these are 1, 2, 3. Our third term. Let's go to our fourth term. Our fourth term is n combination 3, and we do the same thing. We got 10 combination 3, 1 raised to the power of 7 minus 2x raised to the power of 3. And our last term, which is our fifth term, is 10 combination 4, 1 raised to the power of, in this case, to be n minus 4. That's 10 minus 4, which is equals to 6, right? Then b raised to the power of 4, which is minus 2x raised to the power of 4. I'm sure you all got this expansion. Yes, so let's continue. Now 1 raised to the power of 10 is equals to what? Is equals to 1. 10 combination 1. We can represent this 10 combination 1 to give us 10 factorial. 10 minus 1 factorial. 1 factorial. Then minus 2x raised to the power of 1 will give us what? Minus 2x. Is that okay? Now plus, going to this second part, what do we have? 10 combination 2 will give us 10 factorial. 10 minus 2 factorial. 2 factorial, right? Then minus 2x squared, we brought it down here. Is that okay? The same thing here, 10 combination 3 will give us 10 factorial over 10 minus 3 factorial, 3 factorial. Then minus 2x raised to the power of 3, we brought it down here also. The same thing with the last term, that's our fifth term, which is minus 2 raised to the power of 4. We brought it here. Then 10 combination 4 will give us 10 factorial, in bracket 10 minus 4 factorial, 4 factorial. I hope you are all getting. Okay, now plus minus will give us what? Will give us minus, right? That's why we have minus here. Then we have 2x. Now 10 minus 1 will give us 9 factorial, right? So we can break this. I told you in the last class that if I have something like 10 factorial, 10 factorial means 10 times 9 times 8 and so on and so forth, times 8 times 7 times 6 times whatever. So we can represent this to be 10 times 9 factorial. What is 9 factorial? 9 times 8 times 7 times 6, you get. So that's why we have 10 times 9 factorial. So you see, this 9 factorial cancels this 9 factorial. And of course, 1 factorial is 1. So 10 divided by 1 is equals to 10. Is that okay? So in this case, our answer is equals to 10. Do you understand? Now, for minus 2x raised to the power of 2, minus 2x raised to the power of 2 will give us 4x squared. Why is it giving us 4x squared? It will be minus 2x times minus 2x. So minus minus will give us plus. 2 times 2 will give us 4. X times x will give us x squared. And that's why we have plus x squared here. And here when we have 10 factorial, 10 minus will give us 8 factorial. So we can break this 10 factorial into 10 times 9 times 8 factorial. So this 8 factorial cancels 8 factorial. And 2 factorial can be represented to give 2 times 1. So 2 in 2 here, 2 in 10 is what? Is 5, right? 5 times 9, I think, will give us 45. 45 divided by 1 will give us what? Will give us 45. So let's clean this up and make sure our work is a little bit neat. Okay, now let's continue. So here we got what? We got 45, right? Good. Let's continue. Now minus 2x raised to the power of 3, of course you should know by now that it will give us, in this case it will give us minus 8x cubed. and this minus times this plus will give us minus. Do you see? That's what in this case we have minus 8x cubed. Okay, now 10 factorial over 10 minus 3 factorial. 10 minus 3 is what? Is 7 factorial. So we can break this 10 factorial to give 10 times 9 times 8 times 7 factorial. So you see this 7 factorial cancels 7 factorial, whereas 3 factorial will give us 3 times 2 times 1. Is that okay? Now 3 in 9 will give us 3, right? Good. 2 in 10 will give us 5. 5 times 3 is 15. 15 times 8 will give us a value. That value divided by 1. Yes, we'll use that value to multiply 8. Is that okay? Let's clean all this up. I hope you are following me. Make sure you are with your calculator so you can multiply these answers. Let me repeat what I did here. What I did here was that I said 3 factorial. This 7 factorial cancels 7 factorial, and 3 factorial will give us 3 times 2 times 1. So 3 in 3 is 1. 3 in 9 is what? Is 3. 2 in 2 is 1. 2 in 10 is what? Is 5. And what do? You take your calculator and you pick and you multiply 5 times 3 times 8 here. And what do we have at the denominators? We have just 1. So what you get up divided by that 1 will give you your value here, in which you will multiply with 8 to get your values here. Okay, let's continue. Now the same thing with this last term. This last term, minus 2x raised to the power of 4 will give us plus 16x raised to the power of 4. I'm sure you should know how by now. Then 10 minus 4 will give us 6 factorial. So we break this 10 factorial to give 6 factorial. So we have 10 times 9 times 8 times 7 times 6 factorial. This 6 factorial cancels 6 factorial, whereas 4 factorial will give us 4 times 3 times 2 times 1. Are you following me? So 4 in 8 will give us 2, 3 in 9 will give us 3, and 2 in 10 will give us 5. You see, so everything in the denominator is gone. So in the numerator we have 5 times 3 times 2 times 7. To give you a value, that value you multiply it with 16. So that is generally how to solve something like this. Now what do we have here? 1. We have 1 here, and here we have, here we got a value. That value multiplied by, we got 10 here. I think 10 times 2 will give us 10 times 2x will give us 20x. Here we got a value. That value multiplied with 4x squared will give us 180x squared. You must do this with your calculator, but you should be able to use your head, because I think in CBT exams, calculator won't be allowed. So you must be very, very fast in calculating these numbers to get your values. Okay, so we have minus 960x cubed, and in this last part we have plus 3360 x raised to the power of 4. In this case, we have satisfied our question, which says find the first 5 terms of the expansion of this. Is that okay? And if we count these 1, 2, 3, 4, 5 terms. Is that okay? So this is generally how to solve questions of this form. Okay, let's go to our second example. Now our second example says find the 5th term of the expansion 1 minus x raised to the power of 10. Now in this first example we are looking for the first 5 terms. But in this second example we are looking for just a term, and that term is just the 5th term. So we are looking for only one term. Now when you are looking for only one term, let's read what this is saying. It says the general formula for finding any term, just one term, which could be any term, in a binomial expansion or in a binomial expansion is given by, this is the general formula. You must put all this formula in your head. Make sure you don't forget them. Tr plus 1th term equals to n combination r, a raised to the power of n minus r, b raised to the power of r. With the exception of negative integer, that means your raised to the power here must not be negative, and your raised to the power must not be a fraction. It must only be positive. we use this formula. So you use this formula only when your raised to power is positive. When it is a fractional exponent or a negative exponent, of course use another formula, but not this formula. And now, how do we find our r? We find our r by saying r plus 1 equals to our term. What is our term here? Our term is 5, so we can say r plus 1 equals to 5, right? If we collect like terms here, we have r equals to 5 minus 1. 5 minus 1 is what? Is 4. So the value for our r is equals to 4. So that's why in this case we have r equals to 4. And of course our n is equals to 10. Our a is our first term here, which is 1. And our b is our second term here, which is what? Is minus x. Applying our general formula, we have tr plus 1. You know the formula. So what is r? R is 4, right? 4 plus 1 will give us 5. That's why we have t5 here equals to 10. Why do we have 10 here? Because we have n here, and our n is equals to what? Equals to 10. So we have 10 combination 4, and our a is 1. So we have 1 raised to the power of n minus r. That's 10 minus 4, right? Then our b is minus x. So that's why we have minus x here. B raised to the power of r. Our r here is what? Is 4. So that's why we have minus x raised to the power of 4. Now 10 combination 4 will give us 10 factorial over 10 minus 4 factorial, 4 factorial. 10 minus 4 is what? Is 6. So that's why we have 1 raised to the power of 6. Minus x raised to the power of 4 will give us x raised to the power of 4. Why? Because minus x times minus x times minus x times. I always emphasize on this because students tend to make a lot of mistake when doing something like this. Minus times minus is plus, plus times minus is minus, minus times minus is what? Is plus, and x times x times x times x will give us what? X raised to the power of 4. Is that okay? That's why we don't have minus here. I'm sure we all get. Now 10 minus 4 will give us 6 factorial. So we break this 10 factorial to give 6 factorial. So we have 10 times 9 times 8 times 7 times 6 factorial. You see, this 6 factorial cancels this 6 factorial. What remains here? 4 factorial, right? So we can break this 4 factorial into 4 times 3 times 2 times 1. Is that okay? So 4 here 1, 4 and 8 is what? Is 2. Okay, I think I've done it here. 4 here 1, 4 and 8 is 2. 3 here 1, 3 in 9 is 3, 2 in 10 is 5. So 5 times 3, okay, let's do 2 times 7 is 14, 14 times 3. 14 times 3 will give us, let's solve it, that's 3 times 4 is 12, 3 times 1 is 3, plus 1, that's 42, and 42 times 5, 5 times 2 is 10, 5 times 4 is 20, plus that's 210. Is that okay? Let's clean this up to make our work neat. And that's why we have 210, that's 210. Then we have x raised to the power of 4. How did we get x raised to the power of 4? 1 raised to the power of 6 is equals to 1 times 1 times 1 times 1 in 6 places, which will give us what? It will give us 1. So 1 times x raised to the power of 4 will give us what? X raised to the power of 4. And when you simplify all these, you get what? You get 210. So the fifth term of the expansion of 1 minus x raised to the power of 10 is equals to 210 x raised to the power of 4. Wonderful. So this brings us to the end of the part 2 of the binomial theorem. I'm making the video won't be cumbersome to watch, so it will be very it will be short so that it will be easier to watch and easier to understand. So thank you for listening. Make sure you subscribe to our channel, MINNA channel, and make sure you also like and comment. Thank you very much. See you in our next class, which is the part 3 of the binomial theorem. Thank you. May God bless you.